Okay, very good morning to all the colleagues here. Thank you for joining this session. So this session is about subnational policies. And essentially what we know that a lot of modeling is done at the national level. However, there are many big countries that are big states, and the subnational actions become extremely important in terms of impacting and informing energy and climate policies. So this is what this session's discussion is going to be about. And this has been jointly organized by the Center for Global Sustainability at the University of Maryland and the Council on Energy, Environment and Water in India. That's where I come from. I'm Weber and I lead the long-term modeling work at CW. And the colleagues from UMD who will be probably joining online. The time difference is a bit odd for them. Yeah. So again, thank you for joining. I will probably start the discussion with Alicia. Yours is the first presentation. Please come.
All right, great. Hello, everybody. My name is Alicia Zhao. I'm from the Center for Global Sustainability at the University of Maryland. Today, I'll be presenting on behalf of my colleagues listed over here, and I'll be talking about modeling federal and non-federal policies in the U.S. and how together they can help us meet our 2030 NDC. So as I'm sure this audience is well aware, 2020, or this next decade, is going to be a critical decade for climate action. The recent IPCC reports have shown that we need to urgently reduce carbon dioxide emissions and GHG emissions, and at the recent COP, leaders across the world have strengthened their agreements, or strengthened their commitments to the Paris Agreement. And in the context of the US, we have re-entered the Paris Agreement and have pledged to reduce our greenhouse gas emissions by 50 to 52% below 2005 levels by 2030. And so with all of these ambitious climate targets, we can no longer rely on old models that look just at federal policy. We need to think about innovative, comprehensive policies that span across both non-federal and federal actors. So how we think about this is an all-of-society approach, which means that each part of the society has a role to play. And so with using the strengths of businesses, states, civil society, and the national government, we can actually have the best chance of meeting our climate goals. So if you look at this chart over here, this is kind of our concept of this approach. And so the national government is setting the standards, investing in infrastructure, providing incentives and research, but then the local and state governments can accelerate that ambition with their own policies and investments. And then on the business side, they can strengthen the market signal, develop new technologies, and the civil society then can educate each other and create more demand for these new technologies, which in turn pushes the national government to have stricter standards and so forth. So in US history, we actually have found success using this bottom-up approach where non-federal actors have pushed the federal actors to be more ambitious. So 3 examples here: the vehicle emission standards in California and some other states eventually pushed the federal government to have their own stricter standards for vehicles. And also state-level renewable standards, as well as different procurement targets, have really pushed coal down. And so we have a lot less emissions from coal than we would have expected from before. And the final example is state HFC phase-down targets. With pressure from the states as well as industry, the federal government actually adopted its own HFC target recently, 2020. And so this research is actually carried out as a part of America's All In, which is a group of different leaders in nonprofits, businesses, states, universities, cultural organizations, healthcare organizations, and they're all supporting climate action from the non-federal level. So you can see there's a big diversity of these types of actors, They make up about 50% of US emissions, over 60% of the US population, and over 60% of the GDP in the US. So to kind of incorporate this all-in approach and model it, we use the Global Change Assessment Model, or GCAM. And this is an integrated assessment model that has 5 systems: the water system, energy system, climate, socioeconomics, and land use. And we get inputs with like GDP, population, different technologies, costs, et cetera. And as outputs, we get emissions, temperature, concentrations, and energy use. So we're using a specific version of GCAM, which is called GCAM USA. And this has state-level resolution, which means that we can use the 50 states as well as DC as inputs and outputs. So this allows us to use city-level and business-level as well as state-level data to input into GCAM USA and see how these policies contribute towards emissions reductions. So these are the results from our study, and we confirmed that using a blend of non-federal and federal actions, we can indeed meet our target, and we actually land at 52% emissions reductions by 2030. So I'll just walk you through this graph a little bit. So most of the reductions are going to happen in the electricity sector in yellow, and that's mostly through coal phase down as well as displacing that with renewable energy. And we also have transport as the second largest emissions reductions, and that's going to come from fuel efficiency and increased electrification. But one thing to note is that besides these 2 big sectors, we do need to reduce emissions across all sectors in order to meet our target. And that's important because we're looking not just to meet our 2030 goal, but also to do deeper decarbonization after 2030. So you might be wondering, like, what types of policies are actually included in the framework that was put into GCAM. And here I'll just highlight a few and then go a little bit deeper into 2 specific sectors. So in the transport sector, we're seeing phasing out internal combustion vehicles by 2035. In the power sector, we want to achieve 100% clean electricity by 2035. In buildings, we need more investments in electrification. And in industry, increased CCS, as well as reducing oil and gas methane leakage by 2030. And of course, we can't forget the land sector. We want to be able to implement more nature-based solutions and smart agriculture practices, and that'll help enhance our natural carbon sink. So here's a some specific policies related to the power sector, and I've also listed the corresponding actors. So the state and the federal government are going to be needed in order to incentivize 80% clean by 2030, which will put us on the path towards 100% by 2035. But it's also important to have 100% procurement from the electricity buyers. And then I've also listed investments in research so that our energy supply is reliable, as well as training the clean energy workforce. In the transportation sector, we need to mandate the phase out of ICEs, as I mentioned before, and we have the targets of 2035 for light-duty vehicles and 2045 for medium and heavy-duty vehicles, and that's also at the federal and state level. Again, we kind of need all actors to act in order to produce, like the automakers need to produce more zero-emission vehicles, and we also need to procure more zero-emission vehicles in order to fill that gap of retiring ICEs. And finally, we do need to invest also in mass transit and EV infrastructure, which will mostly be coming from the federal government, but can be implemented by all. So this is actually another paper that we published recently that looks specifically at the transportation sector. And we find that the transportation sector needs to reduce emissions by 34% below 2019 levels by 2030 in order to meet the NDC. And with current measures, which includes market forces, existing policies, as well as the infrastructure bill that just passed recently, we only get about a little over halfway there at 19% reductions. So the remaining 15% has to come from a mixture of non-federal action and federal action. So here I've included the congressional EV tax credit that's still in Congress, and some additional federal actions such as fuel economy standards, as well as non-federal action, which can include ZEV mandates as well as municipal fleet targets and so forth. And here's just another study that puts our study into context. We worked with 5 other top models in the US and looked at emissions trajectories through 2030. And all of the models, even though we have different assumptions and technologies and pathways, we all show that the US can reach the 50 to 52% goal by 2030, that it's technically feasible. So again, the electricity and the transport sectors play a big role in this. Electricity has to be decarbonized through accelerated coal retirement and then being displaced with renewable energy. And the transport sector can be reduced through rapid electrification. But again, we do need actions in all sectors in order to actually meet the target. So in conclusion, we show that this all-of-society approach does get us to where we need to be in 2030 and actually provides a robust infrastructure in case with all the uncertainty in the federal government. And states, cities, and businesses are particularly important because they can act as implementers for federal policies, but then also act as backstops if we don't have sufficient national policy. And that's all, and I'll take any questions.
Yeah, great. Thank you, Alicia. And let me open the floor for any questions. Yeah, please go ahead.
Thank you. Very, very impressive work. One question. So the states can, enable mandates and their own regulations. And is there an uncertainty as to whether these policies could be challenged, in courts and then, pull back eventually? Or once a state puts a mandate or a regulation, we can be like fairly confident that that will remain?
Yeah, I think as it stands now, the states are allowed to set more ambitious targets than the federal government. There currently is no federal policy that doesn't allow that. But I guess that could change in the future, but I don't think that's very possible. Yeah, so yeah, I think the US is unique in that way because the states do have a lot of power and independence to kind of form their own policies and mandates separate from the federal government.
Great, yeah.
Hi, Alicia. Thank you for your clear presentation. I'm just curious, does your model could look at the contribution from federal level and state level?
Sorry, is your question, how do we look at that?
The different contributions by federal level policies and state level policies, from what I seen from your presentation, is a combined of them?
Yes, it's a combination of federal and state level policies, as well as city and business level policies to some extent. GCAM USA is modeled at the state level, and so that means that we can create inputs at the state level. And we have another tool actually that's is a bottom-up approach, and we aggregate the different potential emissions reductions at the city, business, and state level and account for any overlaps. And then we input that all together in aggregate at the state level in GCAM USA.
Great, thank you, Alicia. Any other question? Yeah, Jonas, please.
Yeah, Jonas Hirsch, hello. I was wondering, you were already saying that you have a global GCAM and the regional GCAM is basically running sort of beneath it, or at least in a sort of coupled way with one another. What global pathways are you using for the global model? Yeah.
Yes, that's a great question. So we do actually have constraints for the rest of the world as well. I think we have a rest of the world emission constraint, and that roughly follows a 1.5C trajectory. Does that answer your question, or?
I was wondering, basically, is there an
Sure.
Is there an SSP RCP combination under it? So I mean, global GCAM models, this could be a standard pathway that also is submitted to SL 1.5 or something.
Yeah.
Or is this kind of
So
Yeah,
sorry, let me repeat the question for online guests. So essentially the question is there a RCP, SSP combine for the global emission pathway within which you kind of model US state level emissions, right?
Yeah, so we do use the SSP2 pathway, and then we have a rough emissions constraint to show that the rest of the world is being ambitious as well. But it's definitely not absolute that it's going to meet 1.5C in this trajectory.
But is there an RCP pathway that you have at the global level for this analysis? Like is there SSP2 with RCP, whatever combination there?
No, I think we're just using SSP2, if I remember correctly.
Okay. Yeah. Okay, that sounds great. Okay, thank you, Alicia, for your very interesting presentation. Great. So let me also take a step back and now also say how did we conceptualize this particular session? And there's essentially a bunch of national GCAM teams we were interacting. My colleagues Gokul and Reena, who work on GCAM USA. Also there is a GCAM China that is being developed, and I'm leading the development of GCAM India. So when we say this, we simply mean these are disaggregated state level representations of GCAM. Right, so we have different, so much more kind of, but all of these operate within the one global GCAM framework, right? So, and we do have sort of constraints on the global emission pathways. Within that, we have constraint on national pathways. And if the state level is a bit different from national pathway, we could have a different constraint on, so our state could be more ambitious than national level kind of, ambition, right? So all of that could be modeled, and that is where this idea of, thinking about subnational decarbonization kind of discussion, that's where we came from. And it's glad that so many presenters are here with us today for discussing subnational strategies. Sorry, you had a question at this moment.
I had a question, like this GCAM, is it an open source software? So that's why you can implement it at the regional level, create your own model. So it's like something that they can basically download from the internet, I assume. Yeah. Wonderful.
Yes. So something that can be downloaded, but I should say these are models, right? So it takes a lot of kind of training to learn any of these. Right, but yes, as far as the opportunity goes, anybody can use GCAM because this is a community model, and there's also an annual GCAM community meeting where you could actually come and join and learn, more about GCAM. Right, great. So with that, thank you again, Alicia. Now let me request Jonas for your presentation. Please join us. This one.
Let me see. Yes, this one. I'm sorry, I didn't rename it.
Don't worry. Yeah. So you have to use the microphone.
Yes, of course. The presentation, which we'll probably just show in a second, wants to do pretty much a similar thing, but it doesn't use a globally available model to do that, and maybe has some faults due to that, but there are also other benefits. It's about subnational employment opportunities of coal to renewable electricity, so just electricity system transitions under a global model scenario. So here I actually have concretely an SSP1 1.9 Paris Agreement compatible scenario. And these Paris, so I think in this concrete case it's actually a Remind scenario that was from the CEMEX intercomparison project, but doesn't matter actually. These global scenarios, we agree, aren't, not so useful for national and regional decision making alone. You definitely need to interpolate it and get finer resolution so that you actually can talk about short-term concrete investments. And ideally, there's then also a sort of co-benefit story. Why should you implement this at all? So I want to talk about basically a regional sectoral model, an electricity system model here, that is conditioned on such a global scenario. And in principle, the GCAM work that we just saw is exactly that, with more sophistication than I can show, but maybe here it becomes clearer on what it tries to do. There are 4 steps, 3 steps and sub-steps, but I'm downscaling the Paris Agreement compatible global pathway. So I'm splitting up the macro regions, which is, in Remind you have a region, for example, Europe, and determine from there emissions and electricity system generation for just Poland, and use this as boundary conditions then for an electrical capacity expansion model, where I do a bit more detailed resource assessment than you can do on a global level, and then do a capacity optimization on where do we want to build which sort of power plants, renewable, non-renewable, to do what the global model actually did. And finally, I'm trying to find out the job factors. I'm finding out what this means in sort of employment benefits using a simple methodology based on job factors. So you actually have a story of why you would want to do this. For the downscaling bit, the first step, I actually don't want to tell you much more than what I already said. We're downscaling, and actually Lara, who's also sitting in the audience, did a much better job of describing this in more detail on her poster, which would be linked if you go to those slides. I'm getting from there the electricity demand and an emissions envelope for CO2 emissions that I'm reusing in the bottom-up model. I said that the bottom-up model depends on a detailed resource assessment for renewables. So we're for onshore, offshore wind, PV on roofs, as well as PV in the field. We're computing, and this is something where stakeholders could influence results quite a bit, exclusion criteria. So we're setting up basically rules on where can you place renewables. This is also something that IAMs do, but they do it for the world. I can do it for small regions and some 100-meter resolution based on the GIS data sets underlying it. We're placing individual turbines and PV panels then in the allowed areas that are still available after we exclude where it's not possible to build wind turbines, for example. So you don't want it in forests or in nature reserves and so on. I'm placing individual turbines with different configurations, testing out which configuration works best for individual placement. So I'm varying hub height, I'm varying rotor diameter, the capacity of the turbine that's driving it. And after I have this levelized cost of electricity optimal configuration for this particular place, I'm simulating then a fully hourly feed-in over a historical weather year. So I have something like the correlation and so on for all the renewable feed-ins, and I know how much I could build in principle based on this exclusion map. And that feeds into a least cost capacity expansion that here is happening with the Python power system analysis package, PIPSA, where over several investment periods, I'm minimizing the total net present value of capital expenses and operational expenses to run such an electricity system so that electricity demand, as it was in the electrical model, is met in every single hour of this test year for which I'm operating it. And I have this electricity demand also regionalized. Depends on how much into detail you actually want to go. You could also try to add in particular industrial demands for a country, for a specific region and so on. So there's a lot of possibilities to change the results, and I imagine for such a GCAM model it would be very similar. And I'm upholding the CO2 emissions envelope that I found in the global model that corresponds to my Polish country, basically. I'm also allowing for gas and coal plants, so they are modeled individually as, not as units, but as power plants, which are placed somewhere in the region. So I can say, okay, now it makes sense to slowly phase out this power plant. And I'm also have the possibility to include long and short-term storage because I have a full hourly resolution with all the seasonalities and so on for the operation. This gives me then as sort of power system results, and I wanted to show this to you for Poland, but I didn't finish it in time, and so this is from a slightly older report where we did something like this for South Korea, where we found then that to replace the coal, the energy supply in the electricity system by coal over the next 10 years, so this is the brown region in this energy supply plot, and this is pretty much linearly going down and being replaced by new installations of wind and solar in the region with the addition of quite some significant storage capacity, also including long-term storage, so hydrogen installations. There's actually a 10 gigawatt fuel cell included in some sense, so this is problematic. But this would be a way to do how it could be decarbonized. Possibly it's hard to actually follow this route. And when I do now this final step to convert this into the employment benefits that come with such a pathway for the electricity power system, I can follow a simple job factor approach where for different technologies, I just track the jobs for added capacities, for the construction of these new power plants, for the retirement and dismantling of old power plants, as well as for the operation and maintenance of what is in any given year there. And in a comparison of a current policies to a coal to renewable scenario, following where the current policy scenario is more or less what South Korea planned itself to do, we see that the jobs lost in the coal, operating the coal plants actually are by a factor 3 replaced for this new installation in renewables. And this actually also is true in every single province where they lose coal plant units. There is a lot more renewable installation jobs also there. So this would this was the result of a report where we tried this. For Poland, at the moment, it's not looking similarly nice. We're still working on those results. As a conclusion, and possibly I'm not finishing before time, that's good. I showed you that with coupling basically small sectoral, so flexible sectoral models here, an electricity system model, which is a bottom-up model, to extend a Paris Agreement compatible pathway, we get concrete regional investments over time, as well as possible benefits. So here we computed employment co-benefits, but we're already also looking at air pollution benefits in different regions. The global modeling here was that I reused downscaled electricity demands and an emission CO2 envelope. But in principle, you could also go a step further and say, okay, I'm constructing an electricity demand model for the whole global model region. So I think we said that I said already that Remind has a European region. So you could imagine having the same sectoral model, but for the European region in total with the different states represented as different nodes. And then you can, without the downscaling, say that all the different capacities should add up to what the global model is doing. And I suppose GCAM does exactly this when it puts the smaller subnational GCAM under the global GCAM. And so model preparation here is quite data intensive, but also can then be informed by many different stakeholders and so on. And so I'm very interested in actually the comparison of such very detailed one-sectoral models to what a regionalized GCAM or other model is actually doing in any particular region. So just to understand on, do we need to improve GCAM? What is critically missing here? Yeah, thanks.
Great, thank you. Thank you, Jonas. Very interesting presentation. Any quick questions? Yeah, please.
So it's very interesting. You showed the threefold impact of substitution of jobs from coal to the alternative. But do you have a sense of what happens with wages? Like, is the same impact? Like,
So basically, I can directly talk. Very good. With the approach I'm taking, I'm not getting any wages at all because I don't have a representation of concrete workers or the employments themselves. I would need a sort of a economic model component to combine this with, like, think an IMACLIM model or something, and link this into it. And then I could represent actually workers who would get different wages and so on. With this job factor approach, I'm really only seeing this is the absolute amount of jobs being created, lost.
Great, thank you. Very interesting.
Maybe you don't need the economic model. I think that, since you have the numbers, maybe just a census data on wages could give you a good sense of, because that will be a very interesting calculation, like if lifetime earnings are also higher.
Mm-hmm. Yeah, it's true as well.
Great, yeah. So alternative approach is to actually have labor markets represented in some way, and I think in some development happening in GCAM in that direction also for labor markets. But also, I think the kinds of jobs that will be created for solar and all are going to be very different. So it's like in coal, we say in the just transition debates, the coal miners who will be losing the job, and the technical skill required for installing a solar panel and all that is a very different kind of skill required. Those are next level of nuances that the debate is getting into. I think the first level of debate is just the higher level quantitative numbers. That is the number of jobs that could be created. Is it higher in the new pathway, the RE pathway versus the older pathway? So that is, I think many research studies are clearly showing it. And here also you showed it across provinces. It's great. And some provinces do lose, right? Because they might have got some coal plants or coal mines or whatever, right?
So it depended a bit on the scenario. So there were scenarios where there's a positive net gain everywhere, but it also is possible that individual regions do lose, of course.
Yeah. But even at the granular level, it's maybe different kind of people who will benefit. People who are more educated, more trained. So in the just transition debate, I mean, we are trying to get into more sort of next level of complexity to better understand, this gainers and winners and losers kind of, framework. You had a question already.
Just a clarification question. So basically, what you have is per region you calculate the type of investments or that are needed in order to change the energy system, and then you attribute to those investments the number of the people who work. So because it can of course be that you need installations, but they are actually brought from another region or a country.
Yeah. So I'm basically implicitly assuming here that there is some sort of national construction element also happening, because I'm, of course, at the moment just scaling, especially for the regional thing. It's unlikely that wind turbines will be manufactured in every single region, and I'm implicitly sort of assuming that by having a global job factor that doesn't take this into account. You are right that nationally this is more interesting. If all your PV panels basically come from China, you won't get any construction jobs for that.
Yeah, so that's a very important question also, because when in many national analysis we do see people who want to push for renewable energy, will have all job employment opportunities in the region. But the reality is, for example, for India, most of the panels are being imported from China. So that is where the job creation and manufacturing is happening. In India, it's the operation, installation, that kind of job creation that is happening. So it's very important to differentiate these job factors just to better represent the reality of it. Yeah, I'll come there.
Maybe one question. So the employment factors we took, were these on the global or on the national level? Because I think also the job factors we had were like specifically from historical values from South Korea as well. So I think sort of like the local benefits would have been like factored into these factors as well.
So there is a bit of both. So we basically started off from global job factors from Ram and Rutowitz publications a couple of years back. But we basically iterated with some of his methodology together with our South Korean partners in this study to change the job factors so they better reflect the South Korean context. But I'm the wrong person to actually answer the question because I know that was done, but I don't know the details.
Thank you. One final comment on something very important that you talked about is comparison with of these kind of very detailed models with models like GCAM and all. I think, and happy to hear what others also have to say about it. I think the objective of the models are very important. So many times models like GCAM are not for informing planning, like operational planning. Whereas I think a very detailed model which will represent, let's say, load curves, like representational seasonal load curves are more for dispatch planning, which is operational planning. At least in India, that's how many models are used. So they will be talking about next 10 years, but more from the operational and dispatch perspective, whereas GCAM kind of models will be talking about long-term policy, that kind of thing. So of course, there are versions of GCAM also that look at operation and all, but I think from comparison perspective, it will become interesting to also ensure that the objectives of different frameworks that we're comparing are actually similar, not just the quantitative results. Right?
Okay. I know this was a remark, but I want to have a small counter remark in, because I mean my background comes from electricity system models, and so we have seen that with higher deployment rates of renewables and together with storage, it all of a sudden this not only the seasonal variation, but actually so the weekly variation of renewable availability against electricity demand does drive generation shares as well, and changes quite significantly what an optimal share between technologies and capacities would be. And I suppose GCAM is missing quite a bit of the details there. And that's understandable because it's not the focus. But some models like this, there should be a basic like cross comparison more between these very detailed sectoral models, also in the electricity system model to improve the formulation in GCAM and so on.
Sure. Yeah. Sounds great. Thank you, Jonas, again. Yeah. I'll request next presenter, Edmundo, to come and take the floor, please.
15 minutes, right?
Yeah, yeah. You got it? Great.
Hi, everyone. Very happy to be here. I will be presenting it's really a summary of the research that a group of researchers we've been doing over the last 3 years. The study coordinators are myself, Dave Groves from the World Bank, and Adrian Bonsplit from the IDB. And the work is really the collective effort of over a dozen of researchers in all these institutions in Latin America. And that's really what I want to discuss with you today is how we've been using computational models in collaborative planning processes to design national level long-term decarbonization strategies. The three messages that I want you to take away from the presentation are just basically that what has made this study successful at being able to help federal government design policy for decarbonization is that it's an effort to use useful uncertainty analysis in the design of policies at the national level, a very intensive stakeholder engagement that is supported by intensive computational tools, and a framework or a perspective on that uses a cost-benefit logic for analyzing options for decarbonization. And just very briefly, a bit of the background. Like all development banks and nations are now trying to align their policies, development policies, and investments with the Paris Agreement objectives. The big thing today is that we know that it's technically doable to reach net zero. I mean, we don't really need to invent anything new. It's already what we exist. We can actually manage to do that. And just context that technology costs have become like really have changed significantly over the last 10 years as well, which makes even more feasible the transition. It can be an economic opportunity in terms of using more efficiently our resources, preserving our ecosystems, and with that, providing, positive economic externalities. So the work we've been doing has tried to change a little bit the perspective in terms of climate planning. So instead of trying to work with governments in terms of developing incremental changes for implemented climate policy, really the work that we've been doing has come from the perspective of helping them think through computational experimentation how they can do actually foundational changes, structural changes that in the long term could support ambitious transformation for decarbonization. Now, one of the big challenges of these studies is not only talking with different sectors and trying to understand what they can do to actually decarbonize their economies, but also helping them navigate the huge uncertainty that exists with any decarbonization plan. Two big buckets of uncertainty. One that is related to technological changes in terms of cost and performance, which is always difficult to anticipate, and the other has to do with socioeconomic uncertainty, which is always difficult to anticipate as well. How much electricity demand will grow, and so on, as well as how much we can implement in a given policy. The other big issue in these studies is that these efforts should also help planners navigate the trade-offs of decarbonization in terms of the different winners or losers of the implementation of these policies. And kind of like the bottom point here is that the studies have been geared towards helping decision makers and stakeholders understand what sort of business models could be developed for enabling decarbonization at different sectors. And let me just move to the next slide. So I'll briefly summarize the work we've done in 3 countries, Costa Rica, Chile, and Peru. We've used computational models and a framework for analysis named robust decision making to help federal governments in these nations develop robust decarbonization plans that provide net positive benefits to society. And I leave the publications there if you want, in case you want to check them out. I will give kind of like a general overview, but all the technical detail, if you're interested, is like describing these studies with very high level of detail. So in all these studies, we use a planning framework for decision making under uncertainty, which is known in the literature as robust decision making. This is an iterative collaborative planning process supported by data and models in an intensive fashion. And RDM consists basically of 5 phases. Perhaps the most important of those phases is the decision framing phase, in which you have all these stakeholder interactions to actually understand what is the decision context. I will elaborate a little bit more on that. Once you have that, the next phase is what they do is basically, as a response to those concerns, you develop an ecosystem of simulation models that can be used to specifically connect to those concerns that have been, like voiced by stakeholders. And then in the following phases, what you do is that you use those models in computational experiments, usually large scale, and the effort becomes on mining the resulting databases so that we can go back to stakeholders and inform them about how their decisions are vulnerable to certain combination of circumstances. And with this, helping them, focus on what is relevant and, what is not really driving vulnerability, leave it aside. So I'll briefly walk you through what we've done in this these three studies. So fundamental to the work is to start talking with stakeholders. So this is just a brief example of, for each one of these national strategies, we had like this dozen of workshops with hundreds of people. And really the objective of these workshops is understanding what is the decision context. So asking the stakeholders at each one of the sectors, what are the uncertainties that they see with decarbonization, how their own sectors understand success regardless of climate. So for instance, what are the sectorial objectives, and with that, helping them understand how climate policy can be aligned with those in sectoral objectives. And very importantly, also understanding with them what's on the table, what is what they're thinking about investing or regulatory changes that could be used for decarbonization as well. And this slide here shows you just one example of one, like one of these stakeholder gatherings in which you ask people, like what are the metrics that you consider more important, what are the uncertainties, what are the levers, and what are the data that we should use for the study. That's also very relevant because in these exercises, we ask them about like, do you have models, or shall we be using a database that you consider important that has been vetted by your scientist? And this is typically what the result of one of these. And in these studies, like these matrices, we collect like dozens of this, and then we have to, as scientists, summarize them and synthesize them. With that information in the three studies, what we've done is, in response to those concerns, what we do is we develop a modeling platform that can attend those concerns and worries that have been voiced by stakeholders. For instance, that we can make sure that we can simulate the policies that they want to understand whether or not they are good or not, to make sure that we are able to say, this policy helps you meet these specific metrics that you consider important for your sector. And this is a very interesting methodological work because the outcome is really not one model, but a collection of models. And for instance, just to highlight a little bit, for example, in Costa Rica, one of the local universities already had a very detailed, sophisticated energy model. And the idea was, okay, let's just connect that with other sectorial models and a general equilibrium model to understand what are the implications in terms of economic growth and cost. In Chile, for instance, they had a similar setup, but the electricity model was different. So in Costa Rica was the osmosis platform. In Chile was the PCR GAMS-based electricity model. And I just want to highlight that, that's kind of an interesting exercise, like really develop a model based on already the wires that are on the place. And with those models, what we've been doing is, basically going sector by sector and doing an inventory of all the policies that these individual sectors consider to be important. For example, if you talk to the transportation people, they will talk about, of course, electrifying, more public transportation, modal shifts, using more the bicycle and so on. And then in these studies, what we've done is really extract specific goals in terms of what they want to achieve, like X% of electrification by a certain year. And then we make sure that that is captured on our models. And as you can expect, one of the outcomes of this exercise that you can show them, well, in your current path, you're not going to reach carbon neutrality, and with a very specific, granular understanding at the sectorial level why you're not going to be able to do that. And then with their specific national decarbonization policy, also show them through this exercise whether or not you achieve carbon neutrality and which are the sectors that are more contributing to this mitigation outcome. But more importantly, one of the things that has been interesting about these studies is that we take another step, which is really showing them, like, through decarbonization and carbon neutrality, they can also accrue certain societal benefits. For instance, You can save time in cities by reducing congestion through the, the use of more public transport. That has an economic value. That is an economic value that we calculate in this exercise, and we show them, that there's this amount of dollars that you will be saving, less accidents, better health as a result of less pollution. So the work we've been doing is, in essence, integrative, like really trying to be very expansive in the amount of evidence that you can put on the table in these very large, scale planning exercises. So what you can see in this graph, interesting thing in the 3 case studies is that you show that decarbonization is positive net benefit strategy. So, and that those net benefits will increase over time. So that's always something that's very attractive in the studies that when we present it. But that doesn't mean that there are no barriers to actually, take advantage of those net benefits. Regardless, just showing, policymakers that it's in their own self-interest to do these policies has been very, very useful. As I was telling you, so once we have all these things integrated, what we do is usually we run large scale simulation experiments in which we vary assumptions about, like, well, what happens if, electric vehicles do not become as cheap as you expect they will be? Or what happens if you actually do not achieve your electrification objective? So we really explore over a wide ensemble of uncertainties that are related to uncertainties with respect to changes in technology, cost, and performance, and socioeconomic drivers as GDP, population, income per capita. And the other big bucket of uncertainty is how much you achieve with the plan you had set to implement. And for example, in the case of Costa Rica, when we do these experiments, we usually end up with a scatter plot of results like this. Each dot represents a different future, and you're seeing on the horizontal axis, the discounted net benefits of the strategy over the time period of analyze, and on the vertical axis, you're seeing the total CO2 equivalent emissions, the resulting of the implementation of the plan. And over uncertainty, you end up with a very interesting, set of results. For example, you have, a sector in which you see that in many cases, this policy produces net benefits and achieves decarbonization. But you can also see that there's some level of vulnerability to this strategy, right? Which is, in some cases, well, you achieve positive net benefits, but you do not achieve decarbonization. Once you have these results, then you can ask a next question, which is why this is happening. Why is that in some cases I don't achieve carbon neutrality? And by mining these databases, we can help these policymakers understand, for example, in the case of Costa Rica, out of the hundreds of factors that we explore over and all the detail at the granular level, it really comes down to 2 things that are put at risk their plan. One is the unchecked growth of fossil fuel-based transportation, so failure to decarbonize the transportation sector. And the other one is, unsuccessful conservation of their forest cover. So this is an interesting result because out of the 7 sectors we analyze, you really see that there's just 2 sectors that are the most fundamental, in this case for Costa Rica, to achieve carbon neutrality and also have net benefits. And finally, and in Chile, for example, this exercise, we took it to the next level in terms of, well, let's just analyze how vulnerable the decarbonization strategy is. And once we understand those vulnerabilities, let's develop robust alternatives. And of course, what you can see here is 4 different improvements over their national decarbonization commitment strategy, making it more ambitious in terms of mitigation in each one of the sectors, but at the same time incurring in more implementation costs. And so this trade-off gets clarified, through the studies. And anyway, so just to summarize, there are 3 innovations that have been introduced in the studies. One, identifying key assumptions for decarbonizations through computational experimentation is useful for policy, for long-term, the design of long-term strategies. Also very useful in these studies has been, paying attention to estimating the costs and also the socio-economic benefits of decarbonization. And, doing vulnerability analysis, considering emissions, cost, and potential benefits across different sectors. And with that, I'm done.
Thank you, Edmundo. Any quick questions? Yeah, Alicia, please.
Hi, thanks for the great presentation. I just had a question about the benefit and cost analysis. Were there benefits or costs that were hard to quantify or you could not quantify, and how did you deal with that?
Yeah, that's a great question. So, in the two parts of an answer. So the first part is like, when you're doing these interactions with sectors, there are a lot of benefits or metrics that are mentioned, but cannot be scientifically quantified. So, and in these studies, that's something that, you know, we have said, like, you've mentioned this, but there's not sufficient scientific evidence to inform that concern. So that's nice, because the next step is like, you should do research on that. Now, the second part of the answer is, surprisingly, I mean, for example, the IMF and a lot of different groups are already have really good estimates of potential economic benefits, you know, with really rigorous economic approaches to calculating them. So that has been one of the surprises of the study. Like, if you survey the literature, you really found really good numbers in terms of, for example, what is the economic benefit of reducing 1 ton of air pollutants in a city? And that's a very solid number estimated by the IMF in that respect. And the idea of these studies is, well, if it is good and it's, you know, scientifically peer-reviewed, then just bring it into the study and then test what if we're wrong, which is what we do in the uncertainty analysis. So we bring the number and then we test variations on that number to check if it's relevant.
Great. Yes. Any other questions?
Thank you for the presentation, Edmundo. What I'm wondering, when you elicited uncertainties, metrics, and relationships from the stakeholders, I'm wondering which uncertainties came out as prominent, important uncertainties in the Latin American climate policy case, and a maybe more methodological question. I'm wondering if you experienced any confusions about the desired, plausible versus desired futures, because often when we ask stakeholders, I think there is, in my experience, there is a confusion between what is uncertainty, what is goal, or distinguishing between desired and plausible future. So I'm wondering if you experienced anything related to that. Thank you.
Thank you, Sibyl. A great question. All right, so for the first part, it's kind of a difficult answer, because there's really a lot of heterogeneity at the national level and then on the sectorial level in Latin America. But one thing that is recurring is the concern is how big the demands are going to be. For instance, electricity. Like, you know, it's a very interesting context because it's, you know, developing. It's not already in a state of, you know, mature development. So these countries are struggling to keep up with demand. And one of their big concerns is, well, how much demand there's going to be, and that's a recurrent answer, because, for example, in other sectors like, you know, livestock and agriculture, it's sort of like the same. Like, how many, you know, people are going to have these incomes that are going to demand this type of more, you know, protein intensive diet. So that's one of the concerns. And the other one is a great question, actually. When we began these studies, we first, you know, RDM is an iterative approach. So the first iteration in Costa Rica actually was really centered only on exogenous factors like technological costs, you know, like population growth, income growth, and that way in every sector. But then we realized that people were mentioning policies, but there was uncertainty on how much they could achieve. So, for example, Costa Rica had this national plan of, I'm going to reach 30% electrification by 2030. And then on the workshops, people would say, well, maybe not, because there's this regulation, and maybe it's just going to be like 20%. So at that point, that's when you kind of like, in the experimental design, you can say, well, what if we actually explore over uncertainty implementation? And the final bit of the answer is like, what helps a lot is in the XLRM framework, like this matrix in which you kind of like synthesize the decision context, you have to put a lot of emphasis on the objectives, like really asking sectors, what is your specific objective? Because that's really what defines whether or not a policy is going to be vulnerable. And I usually start with that, like, because that's also what I find is the most unclear part of the problem when we began to do these studies.
Great, thank you. So we're running a bit behind time, so thank you again for the presentation. I want to just mention one thing which is very interesting. I think we can take it over coffee. I think what you showed initially was there is a increase in GDP, right? In Chile and the other. So there was very interesting kind of alternative narratives around this particular thing. So if you look at studies long back, which already have been, many times have been done, there is this notion that decarbonization is going to be costly to the economy. If not, then it will automatically happen, right? It will automatically happen, right? But it is costly for the economy, right? But other bunch of studies, including yours, show the alternative thing that, well, GDP could be higher. And I think the one big difference could be how we are even defining economic cost, right? The moment you start including air pollution and those kind of things, which traditionally are not really market traded kind of goods, you will see maybe a lot of benefit. But what many actors do want to think about is like the financials and the market operating kind of thing, where you actually see like economic going down, hit in some way, right? So now that's an interesting kind of tension, but we'll take it over, maybe coffee, that what do we really need to do to better understand these kind of trade-offs and all. Okay, thank you again, Edmund. Thank you. Olga, please, floor is yours.
Do something wrong?
No, I think I'm sorry, but you have to do it like that. Otherwise, there will be some problems, I think.
Okay, that's fine. That can be, but okay, that's fine. Yeah, thank you. So I'm going to talk.
Sorry, you can't put in presentation mode?
No, it's not possible apparently. I don't know why, but well, we'll just work like that. It's okay.
Okay, sure.
No problem. So I'm going to talk about the impacts of regional energy transition on the labor market in the Netherlands. And I think there are like two differences between the presentations that we already saw and what I'm going to present. So the first difference is that I'm analyzing the impacts of not the outcomes of the optimization model that tells, okay, this is the best way to go. But I'm actually analyzing the outcomes of the negotiations between the different stakeholders in the Netherlands put into the climate plan, and also the outcomes of the extensive planning of the regional authorities for the coming years. So what do they want to do, where do they want to invest? And you will probably also see then that back in the mix of the technologies that are chosen, the mix of the investment. And the second difference is that, so I'm looking at the combination of the economic and the labor market model, both at the regional level. So that's also a bit of a difference. Let me see, so I switch here. So this is basically what we would like to look at. This is the investments that are coming from the climate agreement of the Dutch government. That was an outcome of the very long negotiations between the different stakeholders. So where they try to agree upon, okay, this is exactly what we want to invest, this is how we want to go, in order to achieve the 55% emission reductions by 2030 in the Netherlands. And then those plans have been translated by the regional authorities into a certain investments plan. So the regional energy strategies are so-called regional energy strategies. And those, the people at the regional level, they used a type of analysis that we already saw. So, okay, what is possible for my region? I mean, do I have a potential for solar energy? Do I have potential for wind? Do I have a lot of houses that needs to be isolated? And then you see that back in the mapping. In the map, so you see that the distribution of the investments, the total investments between the different regions in the Netherlands is quite different. Most of them are in the urbanized areas, the highly urbanized areas, and why? That you can see back in the graph, where you see into the mix of the investments that are planned for the coming 5 years. So we are looking really what is going to happen in the coming 5 years, because this is the time horizon where the regional authorities work. They do not look at the 2050. So they really want to have some concrete investment plans and to see, okay, what is necessary to implement them. So if you can, if you see that, the bulk of the investments is going to go to the built environment. So basically houses. So that will be isolation of the houses, installation of the heat pumps, switching to electricity, installation of the more efficient electric equipment. And then a second largest part of the investment is the investments into the electrification of the energy sector. So basically we want to produce electricity through the renewable energy. So this is, for the Netherlands, means investing a lot in the wind onshore and offshore, and this is very geographically related, and that you can see here. So this is basically the wind onshore and offshore, which is going to happen. There will be massive investments. Plus there are also, of course, investments into infrastructure that take place all over the regions, because you need to link your now spread facilities for producing electricity with the demand, which is mostly in the urbanized area of the country, just here. Now, how do we go about the analyzing it? So we start from the investment. So we know, okay, this is basically the investments that the regional authorities and the governments want to do in the coming 5 years. So then what we do, we have a look at each of the technologies, and we try to work with the investment matrices, so which we either get from statistics or from expert opinion, from literature, which says, okay, if we want to invest in a wind, then this is the type of the expansion that you have to make. And that can be what we already saw in the previous presentation. So you have to get the equipment, you have to install it, you have to maintain it, and so forth and so forth. And that can be very different depending on the type of the technologies that you look at. And eventually, a part of these goods and services that you have to get in order to implement the investments, you get them from abroad. So they are not, it's not something that is produced in the Netherlands and probably will not be in the coming 5 years, like solar panels, a lot of the metal equipment, and others which are more like services, maybe some parts of the electric equipment. It can be bought within the Netherlands, and that is actually the part which is approximately 60% of the investment, which leads to extra jobs in the Netherlands. And then a next interesting thing is of course, you saw that we have a lot of investments that have to take place in the part of the Netherlands which is a bit remote. There are not that many people, there are not that many companies, but investments are quite huge. But not all of them, they will lead to employment in that particular region. So that's it. Obviously, they will get the people to come or to buy the goods and services from other regions of the country in order to fulfill the demand for this, for the particular, for example, construction workers, or the different types of equipments. They will be bought from different parts of the Netherlands. That's why we use the multi-regional input-output analysis in order to take into account the interlinkages between the regions. So yeah, you are investing here, but that leads to employment maybe in quite a different region, where the production of this specific commodity or a service is concentrated. And the final step, which unfortunately is not in the presentation, it was delayed, but I will just highlight the results that I saw yesterday from the colleagues from University of Maastricht. So they have a regional labor market model for the Netherlands, which is working at the level of about 120 occupations and the types of the educations. And they forecast the labor supply at the regional level. So, and then we can look at the discrepancies. Okay, this is what we have on the labor market, and this is what we need. And then there are certain occupations, mostly technical, where we already have a lot of discrepancies on the labor market. So a lot of shortages on the Dutch labor market. And we see from the results that they will be worsened by all these investment plans that we now have in the energy transition. And for some, for example, for the university-educated engineers, this leads to a quite high increase in discrepancies. Now, when we did the multi-regional input-output analysis, so we did it for the different scenarios. So we had 3 scenarios. The first one was, okay, let's assume that these investments, they just come on top of the current investments. So we will finance them through bonds or just finance now and then pay in the future. And then in another 2 scenarios, we try to have a budget neutrality. So we keep the investment budget the same, but then we try to shift the expenditures. So from other investments, for example, in capital goods such as machinery equipment, into the ones that are necessary for the energy transition, so for this climate transition. And in the third scenario, we are saying, okay, we are looking at the whole bundle of the consumption goods. And then you can think about it as, for example, introduction of the carbon tax, or introduction of an additional tax on consumption for the consumers. So then they will consume less, but we're going to spend more money on that are needed in order to implement this climate policy. And you see, of course, a bit different results there. So if you look at the graph, so we have the relative and the absolute change here. So the relative changes are, you see that additionally we need, there is quite an extra demand for goods produced by machinery, equipment, and metal industry. There is quite some big extra demand for the construction industry, as well as for the specialist services, which include, for example, engineering services, R&D services, and so forth. And you can see that the difference, the big difference comes in the negatives, depending on these 2 scenarios. So in the third scenario, I think it is the most extreme, where we see that the consumer services are being affected negatively. So if we look at it here, so we see that there is also quite some distribution between the regions that is uneven. And then I come to the conclusions. So the conclusions that we made based on this study is that given the current situation on the labor market, and given that all these investment plans, they actually worsen existing shortages on the labor market, there is a quite high risk for implementation of the investment plans. Yeah, so, or you would need to invest more than what has been planned because of increase of the wages, or because you have to train people that are necessary for this implementation of the climate plans. Here I will end. Thank you very much.
Great. Thank you, Olga. Any questions for Olga? Okay, great. So I have this one, question in terms of the labor markets that you're especially talking about. I mean, have countries found a way to address this kind of, like, what is the solution? Because investments are going to come in wherever it's most attractive, right? So, and states, even if they don't have labor, I mean, they would like investments to come in for getting fiscal resources, for many good reasons, because investment means a lot of development in that area, right? Mm-hmm. So is there, for correcting the imbalance, is there any solution that governments have thought about?
Yes, there are a lot of initiatives. So what they want to do is to, because of the shortage of the technically educated people, they want, for example, to encourage women in the Netherlands to follow more technical professions, because at the present moment they're not doing it, very, very little. And they are restructuring also the educational programs. And now they are also talking about migration policy. It is on the agenda because, again, of the shortages. So these are the 3 solutions that are now on the table.
Great. Very interesting. Thank you, Olga. Thank you for your time. So now, you had a question? Sure. Quick question, please.
So thanks for the presentation. That's sounded like this would be an ideal, basically, next step to investigate after the job factors. And therefore, I was wondering where this multi-regional input-output tables, basically, here it was a JRC EC publication that you, I think, took them from. Is this something that...
No, this is something that we as PBL develop for GRC,
awesome.
and that they use for the regional economic modeling. So it is indeed, it's at the level of about 300 regions in Europe, the multi-regional input-output table, plus the rest of the world countries.
Wow. Yeah, okay. Great. Thank you.
Thank you, Olga. Now we'll move to the last presentation, which is the online presentation. Venja, are you there? Can you hear me?
Yes, I can hear you.
Great. So I'm going to I'm going to share the presentation here, and I hope you can see the screen, and I'll be kind of changing the slides, if that's okay.
Oh, sure.
Okay, so this is, can you see the screen?
Sorry, I can't.
Okay.
Oh, here. Yes, now. Yes.
Great. Please go ahead.
So shall I start? Yeah, thank you very much. Good morning. This is Wenjia from Beijing. I work in the energy system models, and also I work on the related climate economist problems, and I work in Tsinghua University. Today I want to share a case study and some of my personal views on how to use subnational scenarios of decarbonization to inform climate policymaking and to promote sustainable development at the same time. I think all countries, they all face multiple challenges, including developing economies, eradicating poverty, improving health, reducing inequalities, and etc. So addressing climate change is only one goal of a government. And therefore, a good low carbon transition pathway should support other development goals. Or as IPCC pointed out, the viable speed and scope of a low carbon energy system transition will depend on how well it can support sustainable development goals and other societal objectives. So many existings have done a good job in doing the one-way quantification. They can perfectly reveal how different decarbonization pathways affect the sustainable development and address these interlinked challenges. But they are in some way insufficient to make detailed suggestions, such as the detailed deployment plans on how the carbon neutrality pathways should be redesigned to balance decarbonization and sustainable development needs. So here, the next slide, I listed out 3 possible ways to incorporate. Would you please turn the next slide for me?
Yeah, I'm trying to. It's not happening.
Thanks. So here I listed 3 possible ways to incorporate the sustainable development into the design of decarbonization pathway. First, we could use the sustainable development impacts to design those phase out or retrofit or deployment or the spatial reallocation plans for a specific technology. And second, we could use these impacts to inform how the future technology roadmap should look like for a region or for a country. And also third, we can use the impacts to inform how we should allocate carbon emission quotas or the amount of carbon tax levied in different regions or countries. This is certainly not a complete list, but I think climate policy is much more complex than just these listed here. So the next slide I want to share is that solution-oriented studies will be very important and useful for policymakers. And we really need to carry out more researches on the risks and benefits related to decarbonization. Just as this figure shows, we need to know that we need to reveal that some of the risks and benefits, they might happen in now or in decades, and might happen here or in some other places. So they have this temporal and spatial mismatch things. So once those temporal and spatial distribution of risks and benefits are estimated, the fundamental transition to a zero carbon society can be easily catalyzed. Just as the previous figure shows, we can easily roll the ball from the present to the future after we consider all these different kinds of risks and benefits and their temporal and spatial distribution patterns. So now I'd like to show a case study from my research group, which was published in the Lancet Planetary Health, on how to use health impacts of decarbonization pathway to inform carbon neutrality pathway design. We all know that there are mainly two carbon neutrality pathways. The first one depends mainly or even completely on renewable energy to reduce those positive emissions as much as possible. So this way they usually have high health co-benefits, but also high mitigation costs. The second pathway uses more negative emission technologies so that they could have more smooth transition in those hard to abate sectors. This pathway has lower co-benefits, but also have lower mitigation costs. So in short, the higher negative emission technology ratio means lower health co-benefits as well as lower mitigation cost. Therefore, in this study, we want to answer two questions. The first one is the one-way quantification. How will China's carbon neutrality target affect people's life expectancy or the health impacts? And the second question is the solution we mentioned at the beginning. So what is the optimal carbon neutrality pathway for China considering its maximum net benefits, which means health benefits minus the mitigation costs? So please, so the next slide shows the modeling framework used in our study, a computable general equilibrium model, and also environment model which helps translate those emissions into air pollutants concentration, and then the health benefit assessment model. And here we use value of statistical life to monetize the health benefits. So the next slide. Yeah, we have set up three scenarios. The ref scenario means no carbon mitigation, which is obviously a counterfactual scenario. And then the ANT-led scenario is that we rely more on the negative emission technology scenario. And then the RE-led scenario means we mainly rely on renewable energy. And then we also couple this carbon mitigation policy with the air pollution control policies, which includes two scenarios, the current air pollution control scenario and also the maximum air pollution control scenario. So the next slide, please. Thank you. So we could find out from the one-way quantification that under this NET-led scenario, the life expectancy in China in 2060 would increase by at least 0.88 years compared to a non-reduction pathway. However, in those more cleaner scenario, the life expectancy increase could be up to 2.8 years in 2060, which is equivalent to 5 to 10 years of public health efforts in China. So, and also the next slide shows that only if we could combine those carbon neutrality climate policies and also the air pollution control policies will make every province in China to meet the WHO guideline standards for PM 2.5, and the life expectancy loss will be avoided as much as possible. And we also have some provincial level results, which I will not go into details, but obviously you could see that our study could reveal those different carbon neutrality pathways according to their different natural and social economic conditions. So next slide, please. And I also want to answer the second question in our study is that we have found out when the proportion of the negative emission technology rises, both the mitigation costs and also health co-benefits declines. It confirmed with our hypothesis at the very beginning. And we also find out the VSL, the value of statistical life, is a very sensitive parameter to the cost-effective analysis. So we made further analysis on different assumptions on the VSL in the next slide. So we could find out under different assumptions of VSL, the comparison or the net benefits or the comparison or which carbon neutrality pathway is more cost effective will change completely. When VSL is small enough, which means we don't really care so much about health, the optimal pathway is the NET-led carbon neutrality pathway. And when VSL is large enough, which is larger than 6.2 million Chinese yuan, which is only like 1/3 of the OECD value. So the optimal pathway would be the renewable-led carbon neutrality pathway. And when we change this VSL from the upper limit to the lower limit, there will the optimal proportion of NET that we suggested to be used will decrease as the right figure shows when VSL increases. So this is the way how we manage to provide suggestions on the most appropriate carbon neutrality pathway. So to conclude my presentation, I really want to emphasize that different carbon neutrality pathway, they have different health impacts for not only for China, but also for other countries. And we need to really properly design those carbon neutrality pathway to maximize those benefits and also to benefit multiple policy goals. And lastly, and also most importantly, those health benefits or other sustainable development impacts, they could be used and should be used to choose an optimized carbon neutrality pathway, both at national and also at the regional level. With that, I want to conclude my presentation, and I welcome any comment or suggestions. Thank you.
Great, thank you, Wenjia, for your presentation. Would there be any questions for Wenjia? Yeah, Casey.
Thank you. Can you explain a little more about the negative emission technology pathway being inherently cheaper in terms of abatement costs? And is it assuming then lots of land use, negative emissions from the land use sector outside of China's borders, or is it not getting into technological abatement? It feels like at that scale, at higher and higher negative emissions, actually costs would be quite prohibitive. But it would be helpful to understand the approach a little better. Thank you.
Thanks. Actually, we combined several kinds of NET technologies in our model. So the basic ones such as afforestation and also the biomass use. So in this way, we are actually comparing to other mitigation costs in those hard to abate sectors, such as phasing out those or like early retirement of the current infrastructure, and also like in the transportation sector and also the residential household sector, where the traditional mitigation costs are comparatively higher. So in this way, we didn't consider these occasions mentioned by you just now about like outsourcing the NET resources from other countries, and also the wider ecological impacts. But we only use those current available and the projected mitigation, the technology cost of using these NETs. So obviously there will be some uncertainties in these assumptions, and that certainly deserves more investigation. Thanks.
Thank you, Wenjia. There's one more question for you.
Hi, Wenjia. I'm Kai from the University of Edinburgh. Thank you for your presentation. So I'm curious how lifestyle change is taken into consideration in your two pathways. And I'm wondering, like, for example, if there's a pathway with the combination of lifestyle change and renewable, maybe the abatement cost can be lower with the health co-benefits?
Thanks, Kai, for this very important question. Apparently, these macroeconomic models, we haven't taken into those lifestyle changes into consideration, but that certainly is very, very important when we are having these transformational changes, both from the supply side and also demand side. And that way, I think considering these demand side changes and those behavioral changes will have a very large impact on the future cost estimation, and also the result won't be so apparent. Something that the changes might be easy, but some changes might also be hard. So I really think that these kind of studies would benefit our understanding of the future complex world. So we haven't taken that into consideration in this model. Yes, thank you.
Great, thank you, Wenjia, and thank you all for attending today. I have our collaborator Reena also, who is the co-organizer. Reena, would you like to give some sort of comments from your side, if you're there?
Yes, I'm here. Thank you, Vaibhav, and also I know we're over time, but I just want to say thank you all the speakers for the excellent group of presentation. I think I learned a lot, and also exciting to see there's a growing of teams and the research focusing on national and the subnational scenarios. I think those are, we all know it's like important to look into the granularity of the strategies for mitigation, but also there's a very close linkage to the other societal goals at all the granular level. So it's like really exciting to see there's a growing attention on those topics. We covered a lot of different topics today in different geography. So yeah, thank you. Sorry if I cannot be there in person, but I kind of really share the kind of the excitement on this topic. And thank you.
Great, thank you, Reena. And let me just conclude by saying, first of all, thank you for your time and for joining this session. I think the modeling capabilities on sort of subnational level are only going to grow in the future, because there are many, many interesting elements. And even if I compare, let's say, the subnational kind of actors in the US versus subnational actors in, let's say, China and India, very different bunch of kind of actors, very different political economy of transition in each of these kind of countries. And national decarbonization pathways are extremely important, and of course a lot of current research has been about national pathways, but only we are able to better understand the political economy, various actors, the kind of investments we are talking about, labor market issues. There are super interesting issues, not just about emission pathways at the state level or the provincial level. It is at the end of the day about how does it fit into the political economy, what is it that does to investments, to labor markets and all that kind of stuff, air pollution, all the co-benefit kind of stuff. So this is a very interesting stream of research that is, I do believe it's going to explode. Many models are going subnational now with more detailed representation, so this is going to be staying there, and we do look forward to kind of continuous engagement with all of you who are doing this subnational kind of analysis in the kind of long-term future also. So thank you again for your time, and have a great day ahead. We'll go for lunch now. Thank you.